All right, today we're going to take notes on Intro to Wave Math. So if you could, just hit pause here and copy this little template down into your notes. And when you're ready, go ahead and hit play and I'll be here for you. So go ahead and hit pause, copy it down. All right, we're back. So before we get some math today, we're just going to talk through a review of terms. So I'm just going to write, this is review because we talked about this the other day. And we'll do term, symbol, units, definition. So I'll write the term over here, and after I write the term, go ahead and hit pause and see if you can figure out what the symbol, units, and definition would be for each of those. And I'm not going in any particular order. Well, I guess I'm going in my favorite order. So Mr. Laurent's favorite order of terms. And I do have all my colors today. So I'm rocking the rainbow. I read a study one time that said that when you take notes in colors, it helps you to memorize them because you can picture them then better when you're going to recall it on a test. So then I always try to write my notes in colors. So, all right, term number one, we're gonna say is wavelength. All right, so take a moment, hit pause, try to do symbol, units, definition, and then when you feel like you got it, come on back. All right, so the symbol for wavelength, let's go a nice little light blue color here. Some people might think it's a W. It's actually this funky one. It's a Greek letter. It looks like an upside down Y, and it's the Greek letter lambda, so we'll say lambda. And then units for wavelength, since they're talking about the length of the wave or how long the wave is, I just automatically think like, oh, that's like the length of like a track in track and field, so it's gonna be measured in, let's go pink here, meters. And just so I don't have to write meters every time, we'll just use the lowercase m for meters. And then definition for wavelength is just the distance. You could just say crest to crest, or you could say trough to trough. So you can say the high point to high point, that distance, or the low point to the low point, that distance. All right, and again, I talk fast. I've had 2 cups of coffee today. Mr. Laurent's feeling good. If I go too fast, always hit pause. Term number 2 is amplitude. So hit pause and try to figure out the symbol, units, and definition. All right, so the symbol for amplitude, we're gonna use an uppercase A for amplitude. Amplitude is how tall the wave is, so it's a measurement again of a height. So in physics, we use meters. And then what's kind of special about this height, it's not from the lowest point of the wave to the highest point. It's actually from the midline, or the midpoint, the midline to the crest would be how tall the wave is. I'll just put in parentheses, how tall. Okay, term number 3. We're gonna go with the wave's period. So same deal, hit pause, see if you can go symbol, units, definition. All right, the symbol for period, in physics we actually use an uppercase T. And the period is the time it takes for the wave to make a complete cycle. So I'm actually gonna skip ahead here to the definition. We're just gonna say it's the time for one complete cycle. And since it's time, in physics, when we measure time, we use seconds. Cool, so it's how much time passes during one complete wave cycle. All right, number 4, frequency. Go ahead and hit pause, get symbol, units, definition. All right, we're back. The symbol for frequency is a lowercase f. Last time we talked about in physics, uppercase F would stand for force, and we haven't talked about forces yet, but we use a lowercase f for frequency. And then again, I'm gonna skip over here. The definition is basically the number, or how often, number of waves occurring or happening each second. So I got kind of sloppy there. So it's how many waves happen each second. And you could say the units would be cycles or waves per second, or you could use hertz. All right, and then number 5, and that's what's going to set us up for some math today. Slide this up a little bit here. Number 5 is wave velocity. And sometimes that's interchanged with speed. We're going to kind of treat them similar for right now. So wave velocity, what symbol do you think we should use for this? What units, what definition? All right, so for wave velocity, we're going to use a lowercase v. So it's lowercase v for velocity in physics. If you use an uppercase v, that stands for voltage. So it's like little subtle things like that. So we'll use a lowercase v for velocity. And then in your car, when you talk about velocity, you're talking about like miles per hour. In physics, we don't use miles per hour. We kind of do sometimes. We usually use meters per second, sometimes miles per hour. And the velocity is just basically how much distance a wave covers, distance covered per unit of time. All right, there's a quick, really fast review of our terms. If that was too quick, again, just hit pause. The big deal today, we're gonna write down period versus frequency. So I left the parentheses there because the symbol for period is an uppercase T, and I just wanted to remind myself of that. That's how long it takes for a wave cycle to happen or occur. And then frequency is a lowercase f, and that's the number of waves occurring. So it says, a wave makes 4 complete cycles in 1 second. And then my question is, what would the wave's frequency be? What would that wave's period be? So if it's saying 4 complete cycles in 1 second, that's describing how often the wave occurs. So they're saying how often, then I'd think that's how frequently. So we'd say, oh, that's saying that the wave's frequency is 4 cycles per second, or you could say 4 hertz. Well, that's fun. My neighbor just started weed whacking in his yard there. So you might hear that in the background, like a little machine. The guy's got a lawn that looks like a golf course. But we'll just ignore that. We'll stay focused on waves. So frequency is 4 cycles per second. That's 4 waves happening each second. So the period, or the time it takes for one of those waves, would be 1/4 of a second. Hopefully that makes sense, because if 4 are happening each second, that means that each wave takes 1/4 of a second. And that gives us our first physics equation, which basically says is that the period of a wave is equal to 1 over the frequency. Or you could write it as the frequency of a wave is equal to 1 over period. Let's put a little box around this one. Cool. Our first physics equations, and we'll take them for a spin tomorrow, but for right now, let's jot them down. I'm gonna put a link to the world's fastest clapper. This dude can clap 14 times per second. And you might be asking yourself, well, why is Mr. Laurent showing us the world's fastest clapper? Well, it really illustrates this point of frequency versus period. Because in the video, you're gonna see the guy can clap 14 times per second. So it's 14 claps per second. So one 1,000, he could clap 14 times. So that means that each one of his claps is 1/14 of a second, which is crazy. That's a lot of claps. But before you watch the video, maybe you can just see, like, just go someplace where it's safe and nobody's gonna judge you, and just see how many times you could clap your hands in 1 second, and then watch this guy, and he's pretty impressive. All right, we're gonna give you one more equation, and then we're gonna call it a day here. So it says equation number 1, general wave velocity equation. And you might be thinking, well, there's equations up here. Yeah, we're gonna use these ones, but really this is the first one that's like, we need to have this one down. So I call it equation number 1, and then we'll get equations number 2 and 3 tomorrow. But if you could, write velocity. And then I put parentheses here because the symbol for velocity is gonna be V. And velocity, if we look up to our chart, it says it's just the distance covered per unit of time. So let's just say, okay, the velocity of a wave is just the distance it covers. The distance it covers per unit of time. So what us physics types want to do is we want to come up with an equation for wave velocity. So we want to look at our terms and say, okay, which one of these variables represents distance from our chart? So which one has units of meters? It's like a side-to-side distance. And we look up here and there's only two that have distance. Amplitude would be like a vertical distance, and wavelength would be your side to side, right? Because it's crest to crest. So for waves, we're going to say, hey, if we want the wave velocity, we're just going to take a wave's wavelength, and we're going to divide it by time in this case. Which one of our variables represents the time? And if you see here, period. So for a wave, wavelength over period, so wavelength in meters, and this is in seconds. If you took the wavelength over period, that would give you how fast the wave's traveling. So wavelength would be the letter lambda over period. So let's write that one down. That's our equation number one here. It says if you want the velocity of a wave in physics, and this is for all waves, sound waves, water waves, light waves, you just take the wavelength divided by the period. And the reason that works out is because the units for wavelength are meters, and the units for period are seconds. So you get meters per second, which that's the unit for velocity, like we said in our table. All right, so there's one equation. I'm gonna write this one down like this. Now my neighbor has a leaf blower out, so if you can hear that noise in the background, that's fun. Yep, there's no leaves, he's blowing the grass that he just clipped. So, sorry about the background noise. Why would I write this like this? You might say, well, Mr. Laurent, lambda times 1 over t. Well, that's the same as dividing by t. But if you look up here, you can see, well, what's 1 over t equal to? Well, that's equal to f. So, I can say, hey, it's lambda. Well, this is equal to f, lambda f. So we get another physics equation today saying, hey, if you want the velocity of a wave, you just take its wavelength times its frequency. So these two equations are really handy for all waves. I'm just going to say all waves. Sweet. So we have velocity is equal to lambda over period over here. So velocity is equal to lambda over period. And then we have velocity is equal to lambda times frequency. And we're going to kind of pause there, and we'll come back tomorrow. But intro to wave math. Make sure you watch this World's Fastest Clapper video because it's super impressive. If you do try it, be careful. I one time had a student trying to clap really fast, and they like slapped themselves in some awkward like way in their face where they look like they hurt themselves or like scratched their face. So World's Fastest Clapper, check it out. Thank you for watching. Have a wonderful day.